So now that we've got some data types from the previous sessions, we're going to start having a look at some operators so that you can play around with them. We're going to go really quickly over basic operators and then have a look at some comparison and logical operators like less than, greater than, equal to, things like that. And hopefully this will give you a good idea of how to manipulate values and have a look at some comparisons. So we might as well just crack on. So we're just going to start with looking at basic operators, and basically it's the same as treating your R script a bit like a calculator. So pluses, minuses, divisions, multiplications, and to the power of as well. So you'll just see here from these sums, once we run this block of code, that they just generate an answer like a calculator would. One more, this to 6 to the power of 2, and then we'll run this block, and there you have it, just answers like you would find on a calculator. R, it's worth mentioning that R adheres to BODMAS, or sometimes BEDMAS, so brackets, other or exponents, BOD, division, multiplication, addition, and subtraction. So you'll see from these two sums that I'm about to do that as again, simple calculation, but adhering to BODMAS where you put the brackets has an effect on the outcome, so just be aware of that when you're typing things in. Some other operators that aren't your bog standard plus and minus are your comparison operators, so your less than and your greater than. Let's have a look what I've written here. 3 is less than 5. 6 is greater than 4. And then you can do the same with decimals. Obviously it doesn't have to be whole numbers. And here you can do a less than or equal to, so you can check things like that, and you can also do greater than or equal to, and you can use the exclamation for does not equal. And now I can tell that I've already made a mistake here, so this isn't going to work. Yeah, that needs to be a double equals. I always forget, and it should be, I think of it as equals means equals and double equals is equal to, and that's what reminds me to put those double equals in. I just changed that bottom one there because they were all coming up as true because I hadn't done anything that was false, so I just changed that one to show you that they can come up as true and false. So this is the one that needs concentrating on because it can get a little bit complicated. So testing for equality in R can be a little bit tricky because it uses a different way of storing numbers than we might normally expect. So it doesn't store numbers quite as precisely as we might want it to, and somewhere at the very end of a large number of decimal places the value might get rounded up incorrectly. It doesn't make a difference to a lot of our calculations, but it will crop up when you're looking at comparing two decimal values. So in our example, if we have a quick look, we think of both of these as 0.2. And if we test 0.2 is the same as 0.2, with the double equals we get a true, which is what we might expect. But then when we come to perform the two calculations and use the double equals to see if they are exactly the same, there's a little bit of imprecision in how they're stored that stops them from being exactly the same number, which is why that returns a false result. And so to avoid this issue, if you're comparing decimal values that come from calculations, it's always better, safer to use the all.equal function, which adds a tolerance to the comparison, which means those tiny little imprecisions are ignored. Because that imprecision is very small, it's usually considered quite safe to use all equal in this instance. So just bear that in mind if that's the kind of thing you're going to be doing within R. So now to have a look at a little bit of logic. So once we do a single check, we more than likely will want to do multiple checks at the same time, and to do that we use a logical operator. So just to have a look at some of the most common ones, the ampersand or and symbol allows us to combine two checks to do an and check, which is, are both things true? The pipe or bar, hopefully you can hunt it down on your keyboard, it can sometimes be a little bit elusive, allows us to do an or check, which is, are either of these things true? And the exclamation point allows us to perform a not check, so we can negate or swap a check's results. And this allows us to say things like, is this check true and that check not true? So feel free just to pause here and have a look at those examples I've typed out. The last one we're going to have a look at is XOR, and it's not very widely used, but it's where you want to check where one and only one of two values being checked is true. Okay, so that's everything. Hopefully these will have taught you how to manipulate and construct comparisons. These are quite important building blocks for data analysis. And at the moment, whilst we've only been working with a single value at a time or a single sum, next time we're going to have a look and see how it works with a bit more data. So I hope you enjoy the exercise at the bottom of the blog, and I will see you next time.